Hi everyone. In this video, Miss Marcus and I are going to show you how to use your calculator for the very first time. So the first thing you want to know is how to input a function. So if we turn on our calculator, you'll come up to the home screen here, and you're going to hit this y equals button. So let's say we wanted to input the function the absolute value of something. So notice if you looked at all these keys here, you don't see an absolute value. So we're going to show you where that is right now. So I'm going to click on this math button. I'm going to right arrow over to num, which is for number. Number 1 says abs. That stands for absolute value. So I'm going to choose number 1. You can either hit number 1 or hit enter there. Now my calculator is a little bit of an older version, so it actually says abs with a parenthesis. We're going to pretend like that's a nice straight vertical line for an absolute value bar. And let's say we want to do the absolute value of x minus 30. This button right here that has a whole lot of stuff on it is actually going to be used for our x. We're not going to use the x somewhere down here. So we like to use this for our x. So x minus 30. Let's say we want to close the absolute value bars. I'm going to use a parenthesis for that. If you have one of those new calculators with the absolute value bar already there, you're going to want to hit the arrow button to get outside of those absolute values.
Notice when you put the function in, Ms. Strader, did you notice how the equal sign automatically highlighted?
I did.
That means that the calculator is going to graph that one for you.
Excellent. That's what I would like it to do. Actually, let's put another piece to this function right here.
Sounds good.
Let's put minus 60, and now we have this absolute value function.
Okay.
So now that we have our function entered into the calculator, we would like to see a graph of it. So I'm going to hit graph.
Wait a minute, Ms. Strader. I just hit graph and mine says error invalid dim.
Oh, okay. So let me go back to y equals for a second. Notice how my plot 1, 2, and 3 are all not highlighted? Okay, so you want to make sure that those are not highlighted. So see, you can go up here, you can highlight them by clicking enter, unhighlight them by clicking enter again.
Are we going to learn more about what those do later?
Yeah, that actually does stuff like scatter plots. Very cool.
Fun.
Yeah.
Not in this video, though.
Not in this video.
Okay.
Okay, so back to my graph, which is kind of disappointing because it looks like mine didn't do anything, but it did. We actually just can't see the graph because we don't have an appropriate window. So notice that this absolute value function was translated 30 to the right and 60 down. So that meant that the point at the origin, that vertex, is now at the point 30, 60. Well, that's nowhere to be seen on this graph. So I'm going to change my window by clicking the window button. And notice that I have a standard window right now. Standard meaning that the x-axis goes from negative 10 to 10, as does the y-axis. So if we need to see a point that's at 30 negative 60, I said 60 before. All right, I want my x-axis to go a little bit beyond 30. So let me try 50. And don't worry, you can try different things. Like if you wanted to put 40 in, I think that's fine. We're just going to be guessing and checking this. I'm going to stop there for a moment just to see how well I did using a different x max. I didn't change my y value at all. But notice I still don't see anything. So it doesn't help me right now. So let's try to change the y minimum. Remember, because this went down 60. So if I need to go down to at least negative 60, I might as well try negative 100. Let's see how that looks. And I hit graph. And now I finally see something.
How come the y-axis is so thick?
So that y-axis, right now, let me go back to my window for a second, is actually, it has little dashes for every 1 unit. And the way that I know that is because of this y scale right here. So if you wanted to make it a little thinner, or actually see those tick marks, you would say, okay, from negative 100 to 10, what would you like to count by? Well, I think most people would count by tens, right? So if I change that to a 10, and I go back to my graph, you'll notice now, you'll see the tick marks.
Oh, but it didn't change the shape of the graph.
It didn't. It didn't actually change the scale of the graph. It just changed the scale of the y-axis, I should say. So right now we have this this absolute value function, this v shape. Important points you want to see on your graph. That would be maximums, minimums, x-intercepts, also known as zeros, y-intercept, right, and the shape. You want to see that basic shape. So I see this v graph already, but notice that I don't see its x-intercepts. I think they're a little bit more to the left and probably more to the right. So I'm going to go back to my window, and I'm going to change that x min. I want to go further left. So right now it's at -10. I'm going to try -30. Let's see how that looks. Very close. I don't know. What do you think? Should we go a little bit further?
Maybe a little bit further. I can really see where it crosses.
Okay. So how about -40? -50? What should we do?
How about -40?
-40. Okay.
Oh, nice.
Nice. Okay. So we have this x-intercept. Now I want the other one over here. So let's change our x max. I'm going to go right to 100. Why not? And again, just like you asked about that y-axis being so thick, now our x-axis is going to get pretty thick. So if you wanted to change your x scale, you could change that to something bigger as well, like 10. So that looks pretty good to me.
Nice.
I see a V. I see this minimum point right here. I see the two x-intercepts. This looks pretty good. So I would say that this is an appropriate window for this function. Just to look at it again. So I would say -40 to 100 on our x-axis, -100 to 10 on our y-axis. So does that sound pretty good?
That looks great.
You want to try a different one?
Okay.
You want to do this one?
Sure. So one thing to note is you can just hit clear when you're in your y equals screen, and that'll clear out the function that you had. And notice it also unhighlighted that equal sign. So let's enter a new function. How about a nice polynomial? How about x cubed minus 6x squared?
So you're using that caret to get exponent?
Yeah, so if we don't have, we have like a squared key, but I like to use the caret because that lets me raise to any exponent I want. So x cubed minus 6x squared plus 7x plus 18. And notice we use this x key again. So anytime you have an independent variable that you want to enter, you want to make sure you're using this key. Another common mistake, make sure if you're doing minus, like in the previous example, you use the minus key. It's different from the negative key.
Those silly Texas Instruments people.
I don't know. They made two different keys.
They don't understand that they're the same thing.
Yes, but on a calculator, it's a different thing. You have to be careful. Notice when I enter that, we have our equal sign automatically highlighted. That means it's going to graph this for us. And one nice thing to notice, if you haven't changed your window from the previous example, your window is still funky. If you ever want to snap back to your standard window that it probably looked like when you started this exercise, we can go to Zoom and then choice 6, Z standard. It's the standard window, which they consider is -10 to 10. So if you double check that when you push Zoom 6, notice that you're back on the original window. So now we can hit graph, and I see something, but Ms. Strader told us that we need to see the general shape of the graph, and this to me almost looks like a line.
Now, Ms. Marcus, I don't know how many of us have seen cubic graphs before, so we might not know the shape.
Well, one thing that's important to note is my favorite point to find first to make sure we can see that is the y-intercept. So even if you're not sure about the shape, we know that if you kind of look at this graph, we know that it's going to cross up here, which is an important point anyway. So if we can at least get there, maybe that'll be a hint as to the shape. So if you look at our function, how do we get the y-intercept? Well, it's a pretty nice point to find. If we plug in 0 for x, we'll get 18. If you look at our window, our y max was 10. So we definitely want to go further than 10. What should we do, Ms. Strader?
I'm feeling adventurous. Let's try 40.
Okay, sounds good. Let's see what that did, if we can at least see the y-intercept. Ooh, that was a nice little guess there. Notice we can see the y-intercept. We can see a 0 down here. And this, in fact, is the shape of a cubic function. So if you weren't familiar with it before, it's nice to know that cubics can have this sort of double hump shape.
I like to call it the roller coaster graph. I don't really know why I do that, but I do.
I wouldn't want to ride that because I'm going to be going up until infinity. But at least
fun.
Negative cubic might be more scary because then you're headed down. But this looks like a pretty good window, actually, with just our guess. You might notice that there's a lot of almost wasted space on the left-hand side. We can see this 0 at x equals negative something over here, not sure. But maybe we didn't just see all of the space over there. So we might want to adjust and make our x-min. We don't need to go as far left as negative 10. Maybe we just need to go to negative 5 is enough.
So it's like shaving off.
Yeah, it's almost like we're trying to manually zoom in.
Nice.
And maybe we know that this is going to continue off to positive infinity as x gets bigger and bigger, so maybe we don't even need to go as far to the right. I'm just being kind of picky now to adjust my window to get a really nice picture. And also you'll find that later when you're doing problems in the future, you might not care so much about a 0. You might care more about the minimum or vice versa. So it's important to know how to be able to see everything at first before you zoom in specifically on something that you want.
Marcus, when you taught us that zoom standard trick, I noticed that there were other things there.
Ooh, interesting. To be honest, I'm not exactly sure the algorithm that the calculator uses for all of these things. Zoom in, I know it zooms in a little bit where the cursor is. I tend to not use any of these. Do you use these, Miss Strader?
I don't. I know that some of my students have used them in the past, and it actually messed them up quite a bit.
Yes.
So I like to avoid them.
Yes.
I haven't used them.
Yes. I think for now, it's important to understand how to get an appropriate window by hand. And some of these, I mean, maybe later in your math career, like zoom stat, I think has to do with maybe if you're plotting a scatter plot or something.
Or zoom trig when we're graphing trig functions.
Yeah, that might be more helpful. But for now, I would say avoid all of these except zoom standard. That's going to be nice to snap you back. The other thing that might kind of feel weird is notice that our window is not symmetrical. That's perfectly okay. It does not need to be symmetrical. I know sometimes it's tempting to go, oh, if I went negative 5 in the min, I have to go 5 on the max. Yeah. No, not necessarily. I think this is do you think this is a good window?
Yeah, I think it's great.
Nice. Anything else you want to add about entering functions, Ms. Strader?
I think we're good.
Yeah, so just be careful. Make sure that you want to investigate, I would say, the type of function you have. If you know that it's an absolute value function, you know it should look like a v. So if all you can see is a line, you're not done. If it's a parabola and you can't see a parabola, you're not done. So just be careful. I would first look at the type of function, and then it's going to be a lot of guessing and checking, a lot of playing around, but you'll be able to get there. And the more you practice, the better you'll get.
Yeah. So I liked doing the video with you. I think we'll do it again.
Yeah, sounds like a fun idea.
Look forward to it.
Bye.